Okay, so now that we have identified ways to find all of the missing characteristics for our different trig graphs, let's put this all together and try our hand at graphing a few. So first thing I want you to do is pause the video and figure out all of the different characteristics for the function you see right here. Okay, pause the video, come back and check. Okay, so hopefully you have these 4 characteristics. I like to also fill in the little thing below here where it says starts, halfway, and ends. So for our sine function, we know that it'll start at, oh my goodness, it's going to start at the midline. Halfway through it'll be at the midline, and then at the end it'll also be at the midline. So for our starts, halfway, ends, will be at the midlines. And then in between the start and the halfway, we're going to be up at our highest point. In between the midway and the end, we'll be down at our lowest point. So that's just my little kind of cheat sheet as I work through this. Now, the first thing I always start with is graphing my midline. So I'm going to graph a horizontal line, and I just do it as a dotted line. Now, this is essentially, think of it as, it's the y-axis, or sorry, the x-axis just shifted down 2 units. So that's where our midline of our graph will be. And then I like to mark the beginning and end of the period. So I know that it's going to start on the midline, so I'm going to put a dot right there on the midline. And then the period length is 2 pi. So I know at 2 pi, it's going to be back at the midline. Now I start to think about, okay, halfway between 0 and 2 pi, that's pi. I'm going to be back at the midline, and that's what I'm using this information for. Now, what I know after that is that halfway between the start and the halfway point, we're going to be at our highest point. Now, our highest point and our lowest point is controlled by the amplitude. So my highest point is going to happen halfway between 0 and pi, which is pi over 2. And that's going to be 3 units above the midline. So that's going to be right here. My lowest point is going to happen halfway between the middle and the end of my graph. So between pi and 2 pi, halfway is 3 pi over 2. And I'm going to go 3 below my midline, which puts me there. Now, for me, before I really connect all of this, I'm going to go ahead and repeat this. So what I know is that every point is both a beginning and an end to a period. So this marks the beginning of the period that follows, but it also marks the end of the period that came before. So because I know the period is 2 pi units long, I know that that period started back here at negative 2 pi. Now, we have the beginning of the period and the end of the period. Halfway between those is going to be another midline point. And then halfway between these two will be now a high point. So we're going to go up 3 units. And then halfway between the middle and the end will be a low point. So we'll be down here at negative 3. 3 below the midline. Now I've kind of filled up that coordinate plane. So I'm just going to connect my points. Make sure, mine's not great, but make sure you try to create curves. And at the ends of your graph, create your arrows. Okay, next up, let's try a cosine graph. Once again, I want you to pause the video and fill in the characteristics to the left. All right, so check your characteristics, see if you have the same things I do. If not, make sure you ask about that in class the next time I see you. Now, with cosine, what we know is that cosine is going to start up at its highest point, and it will also end at its highest point. Halfway through the cycle, it'll be at its lowest point, and then we're going to obviously have to cross through the midline. So our cosine graph, one period, looks like this. So we start at our high point. We also end at our high point. Halfway through, we're going to be at a low point. And then in between our high and low will be at the midline. So first thing I do is graph the midline. This time my midline is at y equals 4. So I just draw in my horizontal line. And then the next thing I do is mark the beginning and the end of a period. Now, I do have a phase shift. My phase shift is left pi over 3. There's a few ways you can deal with this. You could either start with the phase shift, or what I do is I ignore the phase shift until I've got a picture of the graph, and then I'm just going to move everything to the left. So let's go ahead and start with marking with I'm going to do open circles since I'm going to move them. So because cosine starts at its highest point, we're going to start up 1 since that's our amplitude. So I'm going to start up 1. I'm going to use an open circle here. Now what I know is that the period's 2 pi units long, and it's going to end at a high point as well. Now, halfway between 0 and 2 pi is pi, so that's where my low point is going to be. So I'm going to be 1 unit below the midline. And then in between my highs and lows, I will have a midline point. Now this would be my cosine graph if there were no phase shift. Now I'm going to go ahead and fill in the remainder of this graph with what it looks like before the phase shift, okay? So like I said before, the beginning of this period is the end of the period that came before. So I'm going to look at going backwards. So the beginning of that period had to be 2 pi units before, which will be a high point. In between the high and the 2 high points will be a low point, and then we'll have our midline points. Now this would be my cosine graph without any phase shift, but I have a phase shift that goes left pi over 3. Okay, pi over 3 is not marked on this graph. However, we know that pi over 3 is going to be somewhere between pi over 4 and pi over 2. Now, it's going to be, so this is 45 degrees, this is 90 degrees, and we want 60 degrees. So it's going to be a little bit closer to pi over 4 than it will be to pi over 2. But what I'm going to do is I'm going to shift everything left about this much. So I'm just going to put a little marker here where about 60 degrees is. Okay, so we're talking about right about there. This is how much I'm shifting everything left. What that ends up being is maybe one of those lighter colored lines on our graph, maybe a little bit more. We're not going to be super picky about that. So what I'm going to do is use a different color, and I'm going to take every open circle on my graph and just move it to the left about a line-ish. One of those light colored lines. Okay, so we start to get sort of a picture of what this is going to look like. And then I can connect my blue dots to create my cosine graph. Don't forget arrows at the end, and make it a curve, not pointy lines. So let's go ahead and skip ahead a little bit and do the secant graph. So once again, I would like you to pause the video, find all of the characteristics, and then come back and we'll try to graph it. Okay, so check your information, make sure you've got the right stuff on here. Now, I want to talk a little bit about what we're doing with secant. One of the things that you can see with the secant graph is that it behaves very much like your cosine graph, okay? So we're going to start and end at a high point. Halfway through will be our low point. We have our midline points. That would be our cosine graph. What our secant graph does is it takes any of your midline points and turns them into asymptotes. And then what you'll do is you'll just take those highs and lows and create little parabola type shapes in between. And the period length is 2 pi. So what we have is we start, just like we do with cosine, we're going to start with a high point, end with a high. Now I'm saying high as in those are my parabolas that point up. All right, so that's like the vertex of my parabola-ish shapes that point up. Halfway will be at a low, which is going to be our vertex of our parabola-ish shapes that point down. Okay, and then in between we'll have our asymptotes. So that's kind of what we're going to be drawing, is something that sort of looks like that picture. Now, once again, I'm going to start with my midline. So y equals -1 puts me right here. Now, there's no phase shift this time, so I should just be able to graph my function without having to move it afterwards. The next thing I'm going to do is start marking some things. So I start out with my high vertex. So that's going to be a 1 above my midline. The period length this time is only pi over 2. So I'm going to go out to pi over 2 and mark another high point. Halfway between those, well, that's pi over 4, I'm going to be at a low point. And then what I know is that I would have my midline points here at pi over 8 and 3 pi over 8. Those are going to become my asymptotes. So I'm just going to draw those in as asymptotes. Now I just have to repeat this. So remember, this is not only the beginning of the cycle that follows, but it's also the end of the cycle that came before. So the cycle that came before is also pi over 2 units long. So we know it's going to start out at a high vertex point. Halfway between the beginning and the end is going to be a low vertex point. And then halfway between each of those points that I've plotted here and here is going to be, and here is going to be a vertex. I'm sorry, not a vertex, an asymptote. So I will have my asymptotes in as well. Now I can sort of continue to fill in the rest of this graph by noticing some patterns. So what I notice is that my pattern is I have a high point, then an asymptote, then a low point, then an asymptote, then a high point, then an asymptote, then a low point, then an asymptote, and everything is spaced apart by one dark line. So I'm just going to try to repeat that pattern. So I'm at a high point, so that means next I would have an asymptote. So I'm just going to sketch that in. Over here I'm at a high point, so then to the left of that is going to be an asymptote. Now I kind of run out of space at that point, so I don't really need to fill in anything else. But what's going to happen with all of these points that I have plotted is there's just going to be those, I call it, it's not really a parabola, but it's sort of a parabola. So we're looking at sort of a parabola-ish shape that fits in between the asymptotes, and we just fill each of those in. So to graph cosecant, we would do the same thing, except we would start with the sine curve as our model. So if you'd like to try cosecant, you can go ahead to the problem up above, give it a shot. I will graph it out for you, and you can come back and check your answer. Okay, take a look at what I've done. This one was a little complicated because there was a a phase shift, but there was also a change in the period, and it didn't quite fit one period to the right and left of the origin. So if you did okay with this, if you got it at least partially correct, that's fine. Guys, we're going to focus really on sine and cosine. I'm going to have you practice a little bit with the other four functions, but primarily I want you to be able to graph sine, cosine, and tangent. Okay, so let's go try some tangent and cotangent. All right, we're going to go ahead and do the one at the very bottom. I would like for you to fill in all of the characteristics to the left. Don't forget that your cotangent and tangent graphs have a default period of pi. So when you find your period, that's going to adjust how you do that. So take a second, find those, come back and check your answer. Okay, so hopefully you have the information that you see to the left. If you noticed with cosecant and tangent and cotangent and secant, I write where amplitude is vertical stretch, and it is a vertical stretch. It's just going to help us find a couple of points on our graph. So with the cotangent graph, we start out with an asymptote, and then just like every other trig function, it's going to end the same way it starts. So it's going to end with an asymptote. Now, halfway through that, we are going to have a midline point. And then between the beginning and the middle, we're going to be at a high point. And I say high point, this is actually going to be whatever our amplitude is, okay? And then halfway between the middle and the end of our graph, we're going to be at a low point. And again, that's just going to be whatever our amplitude is. That's going to be how our vertical stretch is affected. So let's go ahead and fill all this in. So we start and end with an asymptote. Halfway through, we're at the midline point. And then between the asymptote and the midway point, we're going to be at our highest point, our highest amplitude, our vertical stretch, whatever you want to think about it. And then halfway between the middle and the end, we're going to be down at our lower amplitude or vertical stretch. So once again, I'm going to start with my midline at y equals 1. Now, once again, we will be doing a phase shift. So I will get kind of with these one period graphed, and then I'll shift it, and then we'll fill in the rest of the graph. And you could shift it to the, you know what, let's go ahead and do this one the opposite way. So we're going to actually adjust for the shift to start with. So what I know is that we're going to shift everything right pi over 4. So that means that this pi over 4 indicates the beginning of one cycle. Okay, so that means that we're starting at pi over 4. That's our beginning. Now, the period of our function up here is just pi over 2. So we have to think about moving from pi over 4, pi over 2 units. Well, if you add those together, you're going to get 3 pi over 4, okay? Now, you could look at your unit circle. There's lots of ways you could do this. You could even go to pi over 2 and shift it right pi over 4 units. There's lots of ways you can figure that out, but that's going to be the end of the period. Now, halfway between the beginning and the end of the period, we'll be at a midline point. And then the first half of that cycle, we're going to go up to our higher amplitude. Now this time the amplitude is only a half. So I'm just going to go up a half a unit. And then halfway between the midline point and the end of the period, we're going to be at our lowest point, which is also then half a unit down. So what we have is one cycle of our tangent curve, or sorry, cotangent curve. And it looks something like this. So what we need to do now is repeat that to fill in, the rest of this coordinate plane. So I know that the period is, if I look at the dark colored lines on my graph, this period is 2 dark colored lines. So here's what I know. I'm going to start putting an asymptote every 2, let me make that purple so it matches the rest of this, every 2 bold lines on my graph. So I'm just going to start putting in my asymptotes. And then from there, I should be able to fill in the tangent curve. So I know in the middle of each of those asymptotes, I'm going to have my midline points. I'm going to go ahead and fill all of those in. And then I'll go up to my higher amplitude, then my lower amplitude. And I just repeat that. So I'm just cloning that original period. That's all. And then you fill in the graphs. Again, make these curves not linear. And the amplitude really just sort of helps you to get the stretch of the function correct. All right, if you would like to try the tangent graph above, go ahead and give it a shot. I will go ahead and graph it for you, and you can come back and check it when you're done. Okay, so take a look at what we've got here. See if you agree. If you have some questions, I will do another detailed video for the 2 graphs that I didn't talk more detailed about, and you're welcome to watch those. Make sure you keep a list of any questions so we can talk about those next time we meet in class.